Now the next example under line bodies, we are going to study the behavior of a aluminium truss member. Okay, and the loading conditions of this truss member are mentioned over here. There is a load acting of 2500 Newton, which is acting at an angle of 30 degrees. Okay, and the cross section of this truss is a C section whose dimensions are mentioned over here. Okay, and we have to calculate the deformations, stresses, and also we have to plot the shear force diagram. Okay, now let us see how to perform this in Ansys Workbench. So I will come to Ansys Workbench, and then I'm going to add the static structural analysis system. Now in the engineering data, the first change that I have to do is I need to add the aluminium alloy material, which I have to use for this analysis. Then return to the project and enter into the geometry. Now once you come to the geometry, the first thing that you need to do is you need to set your unit system as meters, and then you can plot these points. Either you can use your sketches to create the sketches, or else we can just uh, plot the points. Okay, so I'm going to use the ZX plane, and in the ZX plane I'm going to create my sketch. The dimensions will be 4 meter by 4 meter. So I'll use my rectangle tool and I'm going to create the sketch. Then we will give the dimensions 4 meter by 4 meter. Go to constraints and add the symmetry. Okay. So now the symmetry has been added. Come back to the modeling tab. And now see, we are going to add the lines from sketches option, and I have created the line body. Now once this line body is created, I will come to body operations, and I will use, you can use the body operation, or you can use the pattern operation. I'm going to create a linear pattern. The geometry is this body, the direction is this direction, and the distance is 4 meters, and we will say generate. So now you can see the body has been generated. Similarly, now next I'm going to plot 2 points whose coordinates would be, in the y direction it will be 4 plus 4, that is 8 meters, and in the x direction it would be 2 meters. Generate. Also in the z direction it will be 2 meters. Okay. I will add another point whose coordinates would be 2 meters, 8 meters, and this z would be -2. Generate. And now I will use line from points, and I am going to create a line body over here. Okay. So now we have 2 bodies, 1, 2, and this is another one. And now 3 line bodies. Now we will connect them. So I'm going to add one more from here to here, apply. So now this and this is one body. Similarly, this, apply. Generate. I can create from this point to this point. Generate. Again from here to here. generate. Okay, then from this point to here, generate. Okay. Now watch the diagram again carefully. We have generated this. Now we need one from this point to this point and one from here to here. Okay. So come back. Need one from here to this point, and the other one we need from this point to this point. Generate. Then next we need one more from here to here. Generate. Check the diagram again. So we have created this, we have created this, and we have created this. Now we need two more from here and here. Okay. So from this point to this point, generate. From this point to this point, generate. And then I need over here and over here. So from here to here, generate. And finally from here to here. So this is the entire line body that we have got. Okay. Now once the line body has been generated, we need to apply the cross section. So first have a look at the cross section dimensions. It is, the webs are 50 millimeters and the thickness is 5 millimeters. So I will come to concept cross section. I need a C channel. Those webs are, you can change, so the millimeter has to be converted into meters. So 0.05, 0.05 and 0.05. This becomes 0.005, 0.005 and 0.005. So this is the C channel that we wanted, and now we will apply this to the truss section and have a look at the model. Okay. Now once the geometry has been created, we will now exit from the design modeler and we will enter into the mechanical window. So double click on the mechanical window. Once you come to the mechanical window, the first thing is we need to change the material for the truss section, and then we will mesh the model by using the default mesh settings. Now let us apply the boundary conditions. According to this, the 4 joints at the bottom are fixed. So I will use the support option, fixed support, and we will select all the 4 points at the bottom. So now they are fixed. And then we have to apply 2 forces which are acting at an angle of 30 degrees. Whenever we have a load which is acting at an angle on a point, we have to resolve them into directions. Okay. So now if this value is 2500 at an angle of 30 degrees, this component, this resolved component will become 2500 into cos theta. Cos theta is 30, cos 30, and this over here will become 2500 into sin 30. So this is how we resolve the forces by using the manual resolution. Now let us calculate these values. Okay. So we will use our calculator. Sin 30 is 0.5 multiplied by 2500 is 1250, and cos 30 is this 0.8660 multiplied by 2500 will be 2165. So note down these values. You can write down these values and then we can apply this. So let us go to the software. Okay. Now we will add the load. I'm going to select this point first and we will resolve it into components. So it is acting in this direction, so it will be one force will act in the x direction, the other one will act in the y direction. So the one which is acting in the x direction would be negative 2165.06 and the one in the y direction will be negative 1250. Okay, and the same load we can apply on this point again. Okay, so it is minus 2165.06 and minus 1250. So these are the forces that we've applied, and this is the fixed support. And now we will add the total deformation as we require. We need the deformations and stresses, and we also need a plot of the shear force diagram. So deformations we know, stresses also we can add using the beam tool, but for plotting the shear force diagram and bending moment diagram we need to have a path. So for creating the path, what we are going to do is click on the model option over here and you have something called as construction geometry. Click on construction geometry and right click on it and insert a path. When you click on the path, you can use 2 points or you can select edges. So I am going to select the 2 points, and now for whatever 2 points you want to create the path, you can add. So I want a path over here. I can use the selection. Okay, let me delete this path. Or you can just select the edges. So we want it for this. Then we also want for this. Okay, you can only select one at a time. So you can select one edge and like this you can now start. So you can select all the edges one by one to define the path, and then over here you can select the path you want the shear force diagram for what parts. Okay, and now we will solve. So we have the total deformation, we have the direct stress, and this is the shear force and bending moment diagram. So you can see the diagram that is generated over here. Okay, So for the three paths, or for the first path that we've selected, similarly you can add one more for another path, the second path that we selected, and then we can solve again. So this plot is for the second path. So like this you can also plot your shear force and bending moment diagrams. Okay. So this is how you will perform analysis on a line body, and now we've understood how to also plot a shear force and bending moment diagram for our 1D analysis.